This is lesson 2.4, solving multi-step inequalities. So your essential question here is, how can you solve a multi-step inequality? So let's look at our first example. We've got y divided by -6 plus 7 is less than -9. Now you're going to do this the same way you would an equation. Remember that our only rule change is that if you multiply or divide by a negative number, we need to flip the inequality sign. So if we're looking at this, the first thing I need to notice here is that I am working with a multi-step equation here. So I've got to look at this and think, okay, just like a regular equation, I need to first, remember we do the reverse PEMDAS, get rid of the add and subtract first. So right now, I need to get rid of what's added or subtracted to the side with the variable. Right now there's a 7 added on. So we're going to subtract 7 from both sides. So that's going to give me y over -6 and -16. Now, if you're looking at this, you're trying to figure out now, I subtracted 7. It was not a multiply or divide, so right now the sign stays the same. So now, to get rid of the -6, I need to multiply, because it was divided by, both sides of the equation by -6. So that those will cancel out, and I would get y, and -16 times 6 is going to be a positive 96. But remember, the number I moved over by multiply or divide was a negative, so I need to flip that inequality sign. So now I would have 96 here. Let's say 96, 97, 98, 99, 100 goes right there. 95, 94, 93, 92, 91, going this way. So if we're looking at this, there's no line underneath, so it's going to be an open circle at 96. And y is greater than, so we're going to go this way on our number line. Let's look at another example here. Again, reverse PEMDAS, get rid of what's added or subtracted. Well, we're subtracting 4, so we do the opposite, which is to add 4. Whatever I do to one side, do to the other. And I will get 2v and 12. Now remember, nothing was multiplied or divided, so the signs are just going to stay the same. Now to get rid of this, remember it's multiplied by 2v, so I need to do the opposite, which is to divide by 2. And I get v, because those cancel out, and 6. But look, the number I multiplied or divided by was a positive, so my sign stays the same. So v is greater than or equal to 6. So let's say that this right here is 6. 10, 4, going that way. It's going to be a solid circle at 6. And then our line is going to go, v is greater than 6. So it's going to be these values on the number line. 6 and up. So now what about when we get to having variables on both sides of the equation? Well, again, you're going to be doing things the same way that you did an equation. So you can still use that foldable that you created to follow those steps as you go through. But the thing you got to remember is the only difference is if you multiply or divide by a negative number, you're going to have to flip the inequality sign. Well, I like having the variable on the left side, so I'm just going to move my 2x. The first step is to put the variable on one side of the equation. So I'm going to subtract 2x, putting the variable on the left side of the equation. And I'm going to get 4x minus 5. And then I've got an 11 on this side. Nothing was multiplied or divided, so we keep the inequality sign. We subtracted 2x, not multiply or divided, so this inequality stays the same. Now your next step here is that you're going to look at this and you're going to decide that you need to get rid of what's added or subtracted to the variable. So right now we're subtracting 5, so to do the opposite is I'm going to add 5. Do to one side, do to the other, and I get 4x and 16. Again, this is a positive, but it doesn't even matter because we weren't multiplying or dividing, so the inequality stays the same. So I'm just going to rewrite this over here. 4x is less than 16. So now comes this final step, is I've got to get rid of what's multiplied or divided. Well, 4 is being multiplied by x, so to get rid of it, I divide 4. So those cancel out, and I get that x is less than 4. So when I'm looking at this, I've got to look and say, okay, here's 4, 5, 6, 7, 8, 1, 2, 3, there's 0. I'm looking at, first off, I need an open circle at 4, and it's going to be x is less than 4, so it's going to be all the values that are less than 4, so going to the left here. Now, there are special circumstances also. Sometimes, when solving an inequality, if you obtain an equivalent inequality that is true, such as -5 is less than 0, the solution of the inequality are all real numbers, or infinite solutions. If it is that, you've got all the numbers, so you've got a line that goes to the left and right. Now, say that you end up with a false statement, like 3 is less than 1, then you're going to have that there are no solutions, so you wouldn't graph anything at all. So let's see how that would happen here. If we're looking at this next example here, let's simplify by getting rid of the parentheses. We've got 8b minus 3 is greater than 8b plus 3. So I'm going to move my 8b over. That's going to cancel out. That's going to cancel out. And I get -3 is greater than 3. Well, that never happens, right? -3 is never greater than 3. So that means there's no solution. And you would not graph this then. Oh, I just realized I made a mistake in here. Hopefully you didn't make the same mistake. I didn't distribute. This should have been 12. But anyways, -3 is not greater than 12, so there still would be no solution. Let's look at this one now. Let's make sure I distribute everything. 10w minus 2 is less than or equal to 7 plus 10w. Subtract my 10w to get everything moved over to one side. Those cancel out and those cancel out. And I get -2 is less than or equal to 7. Well, that's true. -2 is less than or equal to 7. So this is going to be all real numbers. Your arrow's just going to go both directions. Okay? All numbers are going to satisfy this one. So how can we use that in real life? When we're modeling with mathematics, here's the problem that you have. You need a mean score. Remember, mean just means average. You add all of them together and divide by how many you have, how many numbers you have. You need a mean score of at least 90 points to advance to the next round of the touchscreen trivia game. What scores in the 5th game will allow you to advance? So we're looking here at our trivia challenge. Your scores. You got a 95 for game 1. Very impressive. 91 for game 2. Good job. 77 for game 3. You can do better. And 89 for game 4. Nice work. So we're going to start here by looking at how we're going to set this up. You already know, first you need to understand it, and you know the scores of the first 4 games. You are asked to find the score of the 5th game that will allow you to advance. So we need to now make a plan. Use the definition of mean to set up numbers to write an inequality. Then solve that inequality and answer the question. So remember, when we're looking for the mean, we add all those numbers together. So you've got 95 plus 91 plus 77 plus 89 plus our, we'll call it x, is going to be all divided by 5. And this needs to be greater than or equal to 90. So now to solve this, you're going to be looking at, okay, first what I need to do is to find out what all those numbers added together. So if I put those in the calculator, I get 352 plus x divided by 5 is greater than or equal to 90. Now, I know I usually say get rid of what's added or subtracted, but if you notice, this line, this division line, goes underneath both numbers. So it's best to get rid of that first. So what I'm going to do here is I'm going to multiply both sides by 5, just so that I can get rid of this denominator here. So I'm going to have, I'm starting to run out of room here, 352 plus x is greater than or equal to 90. So now I just need to subtract 352. Oh, not 90. I didn't multiply by 5. That would be 450. So now I need to subtract this 352 from both sides. And I'm going to write it over here. I would need x to be greater than or equal to 98. So I need to get at least a 98 on my 5th game, which means I've got to have the best game of all 5 games so that I can get an average of 90 to move on. When you're done with your notes, bring them up for me to check, and then move on to your clever assignment.